Okay, so what do we know about nature of roots till now? Nature of roots, we have seen that if discriminant is greater than 0, the roots are real and distinct, right? Let me write the roots for you. X is equal to minus b plus minus root d by 2a, right? So if d is greater than 0, this number here under the radical sign will be positive, hence the roots will be real and distinct because there is a plus minus sign. There will be one root with plus sign in front of this root d, and there will be another root that will be there with negative sign in front of this root d. Now if d is equal to 0, roots are real and equal, and we have seen that these roots are equal to minus b by 2a. And if d is less than 0, then there will be negative number inside this radical sign, which is not a real number, right? So roots are imaginary, and we also said that these will be in conjugate pairs if the coefficients are real, that is a, b, c belong to real numbers. Okay, another thing that we said was if d is perfect square, then the roots will be rational roots, and if d is not a perfect square, then the roots will be irrational, right? And these will occur in conjugate pairs if a, b, c are rational, right? Okay, and now let me give you a condition. When a, b, c are integers, right? Let me write the roots once again for you. X is equal to minus b plus minus square root of b square minus 4ac by 2a. So I am saying when a, b, c are integers and a is equal to 1, okay, and a is equal to 1, and d, that is b square minus 4ac, is perfect square. D is perfect square. Then the roots will be integral roots, right? So this is kind of condition for integral roots. You can say that if these conditions satisfy, then the roots of the given quadratic equation will be integral roots. Okay, we can also verify this from here, because x is equal to negative b plus minus square root of b square minus 4ac by 2a, and I have said that a is equal to 1 in the condition, so I can say that x is equal to minus b plus minus square root of b square minus 4ac by 2, right? Because I have put a equal to 1, and I know that b square minus 4ac is a perfect square. Now see, 4ac is a number, right, which has a factor 4. So this is clearly an even number. Now there can be two cases here. Either b can be even number or b can be an odd number, because we have already considered that b is an integer. So let us say b case 1, if b is even, then what will happen is, look at this expression inside the radical sign. If b is even, then b square will definitely be even, right? And if b square is even and 4ac is also even, then what will be even minus even? Even minus even will also be even, right? You can check. You can keep on verifying on the right hand side by just taking two even numbers and verifying it. Take any two random even numbers and you will find that their difference is also even. So now I have shown you that this expression under radical sign is an even number in case I started with b being even. Okay, and now you can see that square root of an even number is also even. So this number here is even and b is even number. So minus b plus minus an even number will also give me an even number. And you can see that even number is perfectly divisible by 2. Even number is perfectly divisible by 2, hence it will give me an integer, or I can say an integral answer. Okay, because this is even, and these are separated by plus and minus signs. That doesn't make a difference because the these operations will give a result which is even, and even result will definitely be divisible by 2, hence the answer will be an integer. Similarly, you can see if b is odd, then what can you say about b square? B square will definitely be odd, and b square minus this even number, that is odd minus even number, will again be an odd number, right? Odd minus an even number will again be an odd number. So now square root of odd number, square root of odd will also be odd, right? We started with the condition that b is odd. Now b being odd, b plus my odd number plus minus an odd number, odd number plus minus an odd number, what will be the result? You can verify it here. If you add two odd numbers, these will give you an even number. If you subtract any two odd numbers, they will give you an even number. So the result here will be an even number. And then when you divide it by 2, it will be completely divisible. It will be completely divisible, hence the answer will be an integer, right? For example, if let us say here I got 8, 8 will be divisible by 2 and answer will be 4. So this will be an integral answer. So this is a condition for integral roots, that if a, b and c are integers, a is equal to 1 and d is perfect square, then the roots will definitely be integral roots. Okay, I hope you have understood this, and I've given you the verification steps here. B is an integer. We have considered this in the beginning of this question. So it can be even or it can be odd, right? In first case I took B as even, and I have shown you that the final result, the numerator that you will get will be even, and an even number is perfectly divisible by 2, right? So it will give you an integral answer. In the second case, when B is odd, I've shown you that b square will also be odd, right? And odd minus an even number, which is 4ac, right? B square minus 4ac, odd minus even will also be odd, and square root of odd will again be odd. And now you can say that odd plus minus odd will give you even, and which is perfectly divisible by 2, hence the answer will be integral. So this you can memorize as condition for integral roots. I hope this much you have understood. Now let us see one more important thing here. We have discussed this in polynomials as well as quadratic, that let us say you have got a quadratic polynomial f of x, ax square plus bx plus c, right? If you need to find sum of coefficients, what will you do? You will put x equal to 1, right? So f of 1 will be your sum of coefficient, that is a plus b plus c, right? Now you see, if I've got a quadratic equation ax square plus bx plus c equal to 0, okay, and if somehow I get to know that a plus b plus c is equal to 0, right? If a plus b plus c is equal to 0, what can I say about x? I can say that x is equal to 1, right? This x will have one more value where this will happen, but for now you can x will have one more value where this quadratic will become 0, right? When we put that value, because this quadratic has got two roots, one of the roots will definitely be x equal to 1 if the sum of coefficients is equal to 0, right? You understand? Let me show you once again. If the sum of coefficients is equal to 0, what does it mean? If I put x equal to 1, right, it makes this equation 0, that is a plus b plus c equal to 0. What can I say about x equal to 1? That it is a root of this equation, right? Now if you ever notice that sum of coefficients in a quadratic equation is equal to 0, then you can deduce that x equal to 1 is one of the roots, right? And in what conditions will the sum of coefficients be 0? These kind of questions, it is quite evident that sum of coefficients is 0, where the coefficients are of cyclic nature, right? A minus b, b minus c, c minus a, right? Coefficients a minus b, b minus c, c minus a are of cyclic nature. Now if you add these coefficients, you will see a minus b plus b minus c plus c minus a will become 0. Why? Because a will get cancelled, b will get cancelled, c will get cancelled, and it will become 0. So when you see that there are coefficients which are of cyclic in nature, then you can say that x equal to 1 is one of the roots. X equal to 1 is one of the roots. Okay, so whenever you see that the coefficients, the sum of coefficients is equal to 0, then you can easily say that x equal to 1 is one of the roots. And what about other root? You know that product of roots is c minus a divided by coefficient of x square, that is a minus b, right? So if other root, let us say, is alpha, we already know that one of the roots is 1, so the product of roots is c minus a by a minus b. This means this product of roots is itself the other root, because 1 here can be cancelled, right? Alpha is equal to c minus a by a minus b. Okay, x equal to 1 was one of the roots. I considered the other root to be alpha. Product of roots is constant divided by coefficient of x square. So from here I got to know that the other root is nothing but the product of roots itself. Okay, so this is one of the things that you can keep in mind. One more thing in quadratic equations that you have to keep in mind: if let us say ax square plus bx plus c is given, okay, and it is said that it has got more than two roots, okay, we have talked about this in polynomials also, that if the highest power of x is 2, it can have, or it will always have, two roots, right? It cannot have more than two roots, right? But if it is given in the question that it has got more than two roots, then you can immediately tell that a equal to b equal to c is equal to 0, right? That means this entire left hand side is nothing but 0, and 0 is equal to 0 will be the identity. In this case, this will be an identity. What do I mean by identity? That it will satisfy at infinite values of x, or you can take any value of x and it will satisfy, right? We have talked about it in case of quadratic expressions in the chapter polynomials, so you can go through that also. But for now you can consider that if there is a hint that it has got more than two roots, then clearly the coefficients are all zeros, right? And we have already discussed in case of quadratic equation that a should not be equal to 0, right? So it will not be written as a quadratic equation. If this kind of an equation is written and it is said that it has got more than two roots, then you can simply say that a is equal to b is equal to c is equal to 0. That is, the coefficients of x square, x and constant term are all zeros. Okay, so this was it about this lecture. Okay.